so in this video, we'll do it all. We're starting with P3, polynomials of degree 3 or less, with this inner product, just an integral inner product from -1 to 1. I'm going to start by finding an orthogonal basis for P2, so polynomials of degree 2 or less in this inner product. I'm going to apply Gram-Schmidt to do that. And then I'm going to use this orthogonal basis to find the projection on P2 of this polynomial x cubed plus 1, which is in P3 but not in P2. Alright, so to find an orthogonal basis, what you need to do is first find any basis. Let me make sure I'm putting them in the same order so we can compare with my notes. So I'm going to take the starting basis to be 1xx squared and then I'm going to apply Gram-Schmidt to it. Alright, so let's apply Gram. Alright, so the first basis, we're told just to use the one we have. That's good enough. Now the second one is going to be the one we have. So this is, I'm going to use the same notation, even though it's not quite standard for polynomial, but I want to follow the recipe we just learned. So in the second one, we'll use u2 minus v1 inner product with u2, v1 squared, v1. Alright, so each of these represents an integral, so let me compute them on the side. So here, let me go over there. Alright, so u2v1, that means the inner product of u2 is x, v1 is 1. So it's the integral from -1 to 1 of x times 1 dx. That's x squared over 2 from -1 to 1. That's 1/2 minus 1/2, which is 0. Notice also that this function is odd, so you can say since this interval is symmetric around 0, you're going to get 0. Alright, so u2 we said was x, and then the top here is 0. And so we get just x. Alright, so we have two of them. Let's find the third. v3 is u3 minus u3v1 v1 squared v1 minus u3v2 v2 squared v2. Alright, so before I start erasing things, u3 is the third element in my starting basis, so that's u squared. v1, actually that's, so let's compute it. u3v1 we said u3 was x squared. We just, oh no, it was a bit ago, but v1 was 1. So that's the integral from minus 1 to 1 of x squared dx. That's x cubed over 3 from minus 1 to 1. So that's 1/3 minus 1/3. That's 2/3. Alright, so this one is 2/3. Alright, I need v1 squared. That's the inner product of v1 with itself, so v1 is 1. The integral from minus 1 to 1 of 1, which is 2. You could use a property or you could actually integrate it. I just used the m times v minus a property, so I get over 2 times v1. v1 was 1. Alright, next term we have u3 v2. u3 was x squared. v2, oh, I don't have it anymore. v2 was just x. So that's the integral from minus 1 to 1 of x cubed dx. That's an odd function over a symmetric integral, so I'm getting 0 again. So this one is 0. X. And so I'm getting x squared minus 1/3. Alright, so I found v1, v2, v3. Let's put them together. So the new basis was 1x and x squared minus 1/3. Alright, so this is an orthogonal basis for P2 inside P3 with that that inner product, the integral from minus 1 to 1. Alright, in B we were asked to find projections. So we were asked to find the projection on P2 of, don't remember, it was x cubed something, x cubed plus 1. That's it, plus 1, right? Alright, so we have a formula from before. Now that we have an orthogonal basis, we can apply it. So the projection P2 x cubed plus 1, it tells us to take the inner product of x cubed plus 1 with each of the bases. Elements, so x, length of x squared x, and then the same thing with my final All right, so let's compute all of these products on the side. So let's start with x cubed plus 1. That's the integral from minus 1 to 1 of x cubed plus 1. I get x4 over 4 plus x. So I get 1/4 plus 1 minus 1/4 minus 1. I get 2. The length of 1, we might have found it already. Yeah, we did. It was 2. So I have that first term. It's 2 on 2 times 1. It is just 1. All right, let's look at the next term. I want x cubed plus 1 times x. So it's really the integral of x4 plus x that I want. That's going to be x5 over 5 plus x squared over 2 minus 1 to 1. I'm going to get 1/5 plus 1/2 minus 1/5 plus 1/2. I'm going to get 2/5. Alright, so we found these, we found that one, we're off to this one. X, that's the integral of x squared. That's x cubed over 3 minus 1 to 1, that's 1/3 minus 1/3, 2/3. Alright, I need these final two. I need x cubed plus 1, x squared minus 1/3. I get x5 minus 1/3 x cubed plus x squared minus 1/3. So if this is odd, will give us 0. This is odd, will give us 0. So let's just concentrate on the last two. I get 1/3 minus 1/3 minus 1/3 plus 1/3. I'm getting 0. All right, so what do I get? So let's find the projection onto P2. of x cubed plus 1. We got so 2 over 2, actually let me rewrite the formula, make sure I follow. So x3 plus 1, 1 over the length of 1 squared, 1, plus x3 plus 1, x, length of x squared, x, plus x3 plus 1, x squared minus a third, x squared minus a third. So I got 2 over 2 times 1. X cubed, I don't have any more on the board. I got 2/5. X is over here. That's 2/3. Finally, I didn't compute, oh sorry, I forgot to write it as well. Here I'm missing the length of x squared minus a third. Didn't compute it because since the top is 0, I don't actually need the number. So let's 2 over 2 times 1. And then I said 2/5 over 2/3 times x plus 0 over, I don't know. So finally I get 1 and I get 3/5